So this is a third lecture of our data science using Python series. In this series, third lecture, I will cover the topic exploratory data analysis. So in this series, in this lecture, I cover how to construct a bar graph, contingency table, histogram, and binning list. So first we understand the concept of bar graph contingency table using a Google Doc. After this, I execute the code and explain the code one by one. So first we will explain the construct a bar graph using overlay Python. So what is bar graph? Bar graph is basically a chart that uses rectangular bars to represent and compare different categories or groups. The length or height of each bars reflect the value or frequency of the category. For example, a bar graph can show the number of books read by different students. So let's understand this. So this is an example of our bar graph. This is the example of our bar graph. In this bar graph, ABCD are four students here, and we calculate a count one, count two. That is read books by the student. So this is a code here. So I will explain the code using executing the code using Google Colab. So here this is an interface of Google Colab. If you're not familiar with Google Colab, you can see my first lecture. So first is construct a bar graph. So here we have import a libraries and NumPy for array creation, data creation, and matplotlib for plot creation or bar graph creation. This is a library that contain all types of plots in Python. Next is example data. Categories are divided in four types categories. A, B, C, D are a student. Count 1 is count 2, like this. NP dot arrange length of categories. We will calculate the length of categories and width is equal to we assign 0.35. Plotting bars with overlay. Here we plot the plt dot subplot command. Run the plt dot subplot command. So that figure dot axis ax dot bar, we create a bars of a particular count 1, count 2. So we create a bar for count 1 x minus width divided by 2, count 1 width 0.35, label is equal to count 1, alpha is equal to 0.7. Here alpha is a capacity of bars that is shown in our plot. Next is ax dot next dot set title bar graph with overlay. This is a function used for setting a title. Then plt dot show command is show the plot. Now we run the command. I execute the command here. So run anyway. Now the command is executed. So it takes some time. Sometimes it takes some time. Initializing Python 3 Google Compute Engine backend. It is a connection of our. So this is a graph plot by this command, using this command. You can see this. Next is contingency table. Next topic is our contingency table. So what is contingency table? First we understand contingency table. Contingency table is a simple way to organize and compare data from two or more categories. For example, if we want to count the men and women count yes and no, means I have some example where we need to count how many people say yes and how many people say no. So for different groups we create a contingency table like this. How many males say yes and how many males say no, how many females say yes and how many females say no. So this type of contingency table we create using Python, using this code here. This is a code of our creating contingency table. Now we execute this here. So understand this. Import pandas at pd data, pd.data frame data, contingency table. pd.cross table is basically a command for creating a cross table, creating a contingency table in Python. So we print the print contingency table and we execute this command. So here we can count choice and gender. Choice, and this is a choice and this is a gender. So female, how many females say no in this database? We can see this female, and say no, male say yes, female say no, female say yes, male say no. So here we have only one female that says no, female no. So it is a cross table in contingency table of this data frame. Next is a histogram. What is histogram? We will explain here. Histogram is a type of bar chart that shows now data is spread out the distributed. It divides the data into range called bins, and then tells how many values fell into each range. For example, if you are looking at pupils age, a histogram can show you how many people fell into different age groups like 10 to 20 years, 20 to 30 years, and so on. I will give an example using executing the Python command, a histogram. So here we have a two random sample generate using NumPy library here, 50 to 10, 55 to 12, 100. Plot histogram with overlay. We can give the data one, bins 15, bins 15, bins 15. Next, alpha, it is an opacity label data 1, data 2, color blue, color red. We can set here color. plt.title, plt.title for title creation and plt.legend for two data set. So the plot plt.show using command, we can run whenever we run this command, execute the code, I will give the output here like this. Next is binning based. So what is binning based index? Binning based on predictive value using Python. Binning based on predictive values means dividing continuous data into smaller groups. Bins on how helpful they are for predicting an outcome. Instead of raw numbers, you group similar values together into range. For example, if you are analyzing pupils' age to predict their likelihood of buying something, you could group the age into bins like 20, 30, 30, 40, and prediction, and make it easier to see patterns or trends in the data and improve the accuracy of prediction. So perform binning based, this is a code here. So I will explain the code. So this is the age and income. Age is given as 25, 22, 25, 35, 40 and 50. Income is this. Period data frame, pd dot cut, age, bins, label. We can further divide the labels 20, 30, 30, 40, 40, 50. And after executing this command, we will get the output here. We will get the output here, age, income, age group. So we can understand from here how many people in which age group a person can earn how much income here. So this is all about our histogram and the winning base index and bar graph. So this is a third complete this is a completion of our third lecture series. Now you can continue this series for learning next topic is data preparation phase 2, model the data. Thank you.